today, we're not going to try to tackle all the complex physics in Richard Feynman's legendary lectures. No. Instead, we're going to zero in on just the first 6 pages of Volume 1 and figure out what's so revolutionary about them that it creates this, well, this euphoria of learning. So what is it? What makes a few pages from a physics book, written, over 60 years ago, so incredibly powerful, so legendary? That's the big mystery we're going to unravel right now. All right, to really get the genius here, we have to jump back in time to the early 1960s. Back then, physics education for undergrads was kind of in a rough spot. It was often seen as stale, a total drag, and completely disconnected from all the exciting new ideas of the 20th century. So Caltech decided it was time to do something about it.
See, the standard way of teaching was old-fashioned and really intimidating. It left students feeling like the real, exciting physics was years and years away. Caltech School was the complete opposite. Bring the big, grand, modern ideas right to the freshmen and make physics exciting from day one.
And look, this wasn't just some minor tweak to the course. Feynman himself called it an experiment. He was deliberately trying to break the old mold, to see if there was a better, more profound way to introduce students to the beautiful, interconnected world of physics. So, how does he kick off this radical experiment? Not with some complicated equation, not with a dry definition. Nope. He starts with this powerful hook, a thought experiment designed to just grab your imagination and absolutely refuse to let go.
Seriously, just think about that for a second. If some cataclysm wiped out everything we know, and you could only pass on a single sentence, one that contained the most information in the fewest words, what would it be? This is the huge question Feynman poses right on page 1.
And here is his breathtaking answer. This single sentence, he argues, is the most potent, most powerful piece of scientific knowledge we possess. It's the foundation. It's the bedrock upon which he's going to build everything else. He calls this central idea the atomic hypothesis. It's the belief that the entire material world, in all of its mind-blowing complexity, can be understood by applying just a few simple rules about how these little things called atoms behave. Okay, but here's where the real magic happens. Feynman takes that one sentence and uses it to explain, well, pretty much everything.
From that one simple rule, he shows you how to understand the world. Heat? Oh, that's just the random jiggling of atoms. The pressure in your car tire? That's just countless atoms striking the inner surface. He even bridges the gap to biology, explaining how the structure of a bee's eye is a compromise that's fundamentally tied back to this atomic view. His method is a lot like learning chess. The traditional way forces you to memorize 1,000 different opening moves. But Feynman, he just shows you how the pieces move. Once you deeply understand those basic rules, you can start to figure out the entire complex game of the universe for yourself. And this gets to the impact this method has on you, the learner. Reading these pages isn't just about absorbing facts. People who've read it describe it as an intellectual delight, a true euphoria of learning. So, how did he create this feeling? Well, his lectures weren't just lectures. They were like carefully scripted, dramatic productions. He'd introduce a puzzle, carefully build up the concepts piece by piece, and then bam, the climax, where a single, simple physical law makes everything snap into place. That's the aha moment. This whole thing represents a fundamental shift in focus. It's not about memorizing formulas to get the answer. It's about building a deep physical intuition and learning to think logically, so you can truly understand why things work the way they do. Now, it is worth noting that there's a bit of a modern debate about these lectures. Are they truly for absolute beginners? Some will argue they're perfect for grasping the core concepts and learning how to think, but others say they're terrible as a primary textbook because they don't really teach you how to solve standard exercises. They might actually be best for a second pass over the material. So when you boil it all down, what are the lasting takeaways from these first few pages? Well, they can be distilled into 2 powerful principles for how to view nature. The first principle is this: despite all its mind-boggling complexity, nature possesses an intrinsic, elegant simplicity. At its heart, the world is built on a few simple, beautiful rules. And the most fundamental of these, as Feynman establishes from the very first page, is that everything is just atoms, following the rules of motion. And that brings us to the second principle. Understanding anything complex isn't a one-time event. It's a spiral. You don't just learn a concept once and you're done. You return to the same ideas again and again, each time with more depth and more context. Feynman's method provides the glue of intuition that ties all these passes together, forming a truly profound understanding.
And that leaves us with a final question for you. If you were to apply Feynman's method to a subject you want to master, what is its atomic hypothesis? What is that one single core sentence that contains the most information, the one idea from which everything else can be built? Find that, and you found the key.